Hello everybody, we're getting ready to do lesson 14 of SAT Math Level 2 Prep. And for today's lesson, you got 4 points here on your notebook guide. 6 points will go into your classwork sheet. 14 is about polar coordinates, definitions and relationships to rectangular coordinates. Name, date, period, students in my classroom. Due date here for onliners, homeschoolers. And let's go into page 1 here. Although the most common way to represent a point in a plane is in terms of its distances from two perpendicular axes, there are several other ways. One such way is in terms of the distance of the point from the origin and the angle between the positive x-axis and the ray emanating from the origin going through the point. So this will be an example here of that kind of coordinate here. You have your angle measure, and so that emanates from your origin here. So you have r theta would be out here, and then also you have the point would be have an xy coordinate as well. Will be another way of depicting that. In the figure above, the regular rectangular coordinates of P are xy, and the polar coordinates are r theta. If r is greater than 0, it is measured along the ray of the terminal side of theta. If r is less than 0, it is measured in the direction of the opposite ray. Since sine theta equals y over r, cosine theta equals x over r, there is an easy relationship between rectangular and polar coordinates. So x equals r cosine theta, and then y would equal r sine theta. X squared plus y squared equals r squared using the Pythagorean theorem. Unlike the case involving rectangular coordinates, each point in the plane can be named by an infinite number of polar coordinates. Okay, so, and this is page 2, goes in your notebook guide. So let's go into an example of some of this now. So we have here we have 230 degrees, 390 degrees, 330 degrees, -2, 210 degrees, then -2 and -150 degrees, all named the same point. So in general, a point in the plane represented by r theta can also be represented by r theta plus 2 pi n, or negative r theta plus 2n minus 1 pi, where n is an integer. So here you could rename it in an infinite number of ways by how many times you go around in a circle on the coordinate plane. Express point P, whose rectangular coordinates are 3 and then 3 times the radical 3, in terms of polar coordinates. So r squared equals x squared plus y squared, and plugging these values into that, you would have 3 plus see r squared here. See, r squared will be 9 plus 27 equals 36. So x squared plus y squared equals r squared for that situation there. You get 9 plus 27 equals 36. And then r would equal 6 in this situation here. You would find r by using this formula here to find r. And you plug in your x and y here and you come up with 6. So r cosine theta equals x. And cosine theta would therefore equal 3 over 6, which would equal 1 over 2 for cosine theta. Therefore, if theta equals 60 degrees, when cosine is 1/2, it's a 60-degree angle. And then 6 and 60 degrees are the polar coordinates of P. So that's the way that you find polar coordinates. Moving first from a rectangular coordinate here. Okay, so describe the graph of r equals 2. So r squared equals x squared plus y squared, and so we know r equals 2, so therefore we plug in our values into what we know, x squared plus y squared equals 4, which is the equation of a circle whose center is at the origin and whose radius would equal 2. Describe the graph of r equals 1 over sine theta. So in here, since r sine theta equals y and r equals 1 over sine theta, y would equal 1. In this situation here, the domain of r equals 1 over sine theta is all real theta that are not multiples of pi. So that would be your domain of that. So that would be a description of your graph of r equals 1 over sine theta. Thus, r equals 1 over sine theta is the equation of a horizontal line with holes in it at multiples of pi 1 unit above the x-axis. Both r equals 2 and r equals 1 over sine theta are examples of polar functions. Such functions can be graphed on a graphing calculator by using polar mode. Enter 2 into R1 and graph using Zoom 6 in the standard window, and then this is what you should have here for this one, r equals 1 over sine theta. And that is lesson 14, polar coordinates, SAT Math Level 2 Prep. If you need review, I have packets that you can obtain that will help you review polar coordinates at animated PowerPoint math video at AOL.com. Thank you very much.